This portion of the lesson is going to focus on another type of transformation, which is a translation. So a translation is really essentially just a slide. So it means to vertically and or horizontally slide a figure. So it's going to be sliding it left or right or up or down. That's what a translation is. So symbolic form, so they're going to give us a way of writing the formula that tells us how to move the figure. So we've got x plus h and y plus k. H represents the horizontal horizontal shift, meaning how it moves left or right, so left or right, and then K represents the vertical shift. So that's going to tell us how much to move the original figure up or down. So it'll be x plus or minus a number, y plus or minus a number. That's going to tell us how much to move left or right. This is going to tell us how much to move up or down. So our first example, of course, we've got to plot our points. We should have a rectangle. Make sure when we label the original points, they're actually being labeled with the correct letters here. So I've got -6, -1, and that's Q. Then I've got 1, -5. So that should be S. So 1, 2, 3, 4, 5. Okay, then I've got -2, -7, which is a T. And then I missed R. That's what happened. So we've got -3, +1 is R. So Q, R, S, T. So connect our dots. We should have a rectangle. And so what we're doing today, or with this lesson, is sliding a figure. They're giving us this rule, and what they're telling us is to add 5 to all the x coordinates. So basically, if I'm adding 5 to all the x coordinates, I'm moving all of these coordinates 5 over. So if I just did it one thing at a time, I'll show you the first one kind of slower, and then we'll move a little quicker. So I would move over 5, everything over to the right 5. So I've got 1, 2, 3, 4, 5. That's where R is now. Then I've got Q, 1, 2, 3, 4, 5. This is where Q would be. S goes 1, 2, 3, 4, 5. So there's S, and T goes 1, 2, 3, 4, 5. So technically, since this is a transformation, we would have the little prime symbols. And so this isn't our answer. This is just me moving according to the transformation on X. Now I also have to move it according to the transformation on Y. So Y is telling me to take all the Y coordinates and add 7 to them. So it's telling me to move everything up 7. So I'm going to move Q up 7. So 1, 2, 3, 4, 5, 6, 7. So you could actually label this as Q double prime. It means that's the second transformation to the original figure. R goes up 7. 1, 2, 3, 4, 5, 6, 7. T goes up 7. 1, 2, 3, 4, 5, 6, 7. It's going to end up being on this axis. And then S goes up 7. So 1, 2, 3, 4, 5, 6, 7. So really, once I have done both translations here, this is the final figure. So we need, when we write our final ordered pairs, I had 1 prime and 2 primes because I did each action separately to show you what was happening. But really, we're just writing the ordered pairs for the final transformed figure after both things are done. So for Q, we should be looking at, reading from the origin, it is -1, +6. For R, it is, looking at the origin here, it is over 1, 2, so over 2, up 8. For S, it is over 6, up 2. And for T, it is just over 1, 2, 3, and 0. So we're actually going to check to see if I did this right by now applying these rules straight to the ordered pairs. So I'm going to take all of the original ordered pairs And for all of the x coordinates, I'm going to add 5 to them. So negative 6 plus 5 is negative 1. Negative 3 plus 5 is a positive 2. 1 plus 5 is 6. And negative 2 plus 5 is 3. Checking the y coordinates, I'm going to take all the original y coordinates and add 7 to them. So negative 1 plus 7 is 6. 1 plus 7 is 8. Negative 5 plus 7 is 2. And negative 7 plus 7 is 0. So for the next few, we're going to actually apply them to the coordinates first. I just wanted to show you what it was looking like. We're going to apply them to the coordinates first and then just plot our final transformed figure. So let's take a look at number 2. On number 2, they're telling us to take this triangle. We will plot the original points to see where it was. C is at 2, negative 1. D is at 7, negative 4. And E is at 4, 1, 2, 3, 4, negative 6. So this is our original triangle. And before plotting the points, we're just going to apply the rule to the ordered pairs. So we're taking all of the x coordinates, and they're telling us to take 3 away. So I've got 2 minus 3, which gives me a negative 1 for C. 7 minus 3, which gives me a 4 for D in the x coordinate. And then we've got 4 minus 3, which gives me a positive 1 for E's x coordinate. Then we're going to look at the y's, and it's telling us for all the y coordinates to add 8 to them. So we've got negative 1 plus 8, which is 7 for C. Negative 4 plus 8, which is a positive 4 for D. And negative 6 plus 8, which is a positive 2 for E. So now I can just go and plot the points here for my final transform figure. Again, you could have slid each one and done that, but now I can just plot the points. So I've got negative 1, positive 7, that is C prime. Then I've got 4, 1, 2, 3, 4, 1, 2, 3, 4, this is D prime. And then E prime is happening at 1, 2. So this should be our translated figure. So it went back 3 and up 8, and that would be the final answer. So you can do it physically first, then write the points, or you can change the points and then do it physically. So I want you to try numbers 3, 4, 5, and 6 on your own. Now let's look at 7 together. On number 7, they're actually giving us the original figure and the transform figure. So they're giving us the pre-image and the image, and they want us to write the rule. So for the rule, we're going to look at what happened to the x coordinates, and it's going to be x plus or minus a number. And then we're going to look at the y's and do y plus or minus a number. So we need to know how much they moved left or right and how much they moved up or down. So the big idea here is make sure you know which one's the original and which one's the new one. It's because I got to start with the original and move to the new one. The big idea here is I don't actually have to check all 3 points because they should all be moving by the same amount if it was done correctly. I just need to pick any coordinate, say I choose D, and I just need to look at how D moved. So D went to the right, 1, 2, 3, 4, 5, 6, 7. So it went to the right 7, and since I went to the positive 7, my rule is going to say x plus 7. Now when I'm looking at what happened on y, D went up 1, 2, 3, 4. So it went up 1, 2, 3, 4. So the positive movement on y was going up 4, so it is y plus 4. Now if it had gone back to the left, it would be minus, and if it had gone down, it would be minus. So we're just focusing in on one of the coordinates. Now you're certainly welcome to check all 3, but they're all moving the same way. So you can just pick one of the coordinates and see how it moved over and how it moved up to write the rule. So number 8 is another one you're going to try on your own. Now numbers 9, 10, 11, and 12, we're going to do 2 of them together. We'll do 9 and 10, but this is actually telling you to do a reflection which was the first lesson we learned, and then a translation. So we're going to need to do both things and give our final answer. So we actually learned some shortcuts that could save us a lot of time. For number 9, I'm going to go and do everything physically to show you how it would look. And then for number 10, we'll try the shortcuts. So on number 9, first order of business, we've got to plot the original ordered pairs. So I've got x at -3, 7, y at -2, 1, and z at -5, 2. So 1, 2, 3, 4, 5, and there's z. So here is our original triangle. So they give us a specific order to do this in. They tell us that we need to reflect it in the y-axis. What they mean is reflected over, the x-axis. So we got to remember this is the x-axis. This is the line of reflection. So everything has to be equal distance from that line of reflection. Y was 1 up, so now it is 1 down, and I'm going to put a prime next to it. Z was 2 up, so it needs to be 2 down, so I'm going to put a prime next to it. And X was 7 up, so on the same grid line here, I'm going to go 7 down and put an X prime. So here is our triangle after it has been reflected. And then, so that part's done. The next piece is we're going to take this red triangle, the one that's been reflected, and we're going to translate it. So we're going to move it 9 to the right and then up 2. So I could take y and I can actually physically count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9 over. 1, 2 up, and this would be the final y double prime. I'm going to do that just because I've got 2 of them. This would be the final y. Z, if I moved it 9 over and up 2, be 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2. There's my Z double prime. And then X, I'm going to move over 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2. And there's my X double prime. And here's our final triangle. Now there's nothing wrong with that. You can certainly do that. Show each step and then write your final ordered pair. So our final answer for X would be, it is going over 6 and down 1, 2, 3, 4, 5. So we've got 6, -5. Y is over 7 up 1, and Z is over 1, 2, 3, 4 up 0. So we could do that, or we're going to look at number 10, how else we could have done it. So on number 10, actually just realized we have y equals x as a line, so we're actually not going to do number 10 because that's one of the vertical lines. I'm actually going to do number 11 with you. So number 11 will be one we do together, so we should be okay. Alright, so on number 11, I need to translate it first. So I'm going to kind of write over to the side here my translation. I'm going to write what's happening to L, M, N, and P. So I'm just kind of seeing what's going to happen from my translation. So I'm going to go ahead and label my original order pairs. I've got -2, 7 is L, M is at 2, 3, N is at 0, 1, and P is at -4, 5, 1, 2, 3, 4, 5. Okay, so here's our original rectangle, the one that we're about to do a translation and then a reflection. Okay, so when they give you an order, it certainly matters. You need to do it in the order they give you. So we're going to do the translation first. Now, I'm not going to draw all of this on the graph. I'm going to do this piece algebraically. I'm going to actually just calculate it out. Because now we know that that +6 means to add 6 to all the x's. That -8 means to -8 from all the y's. So I'm going to do -2 + 6 is a +4. 2 + 6 is a +8. 0 + 6 is a 6. And then -4 + 6 is 2. Then when I look at the y's, I've got 7 - 8, which is -1, 3 - 8, which is -5, 1 - 8, which is -7, and 5 - 8, which is -3. So that's where the points are going to be once I translate it all over the place. And then I need to reflect it over the y-axis. So if you remember, okay, the y-axis is the one that's straight up and down. And when we reflect things over the y-axis, the y-coordinates stay the same. What happens is that the x-coordinates change their signs. So we're going to take these ordered pairs from the translation, and we're going to just do this trick, this observation that we notice, that if it's over a y-axis, I can keep all the y-coordinates the same. So -1, -5, -7, -3. And what's going to change is that all the x-coordinates here are going to change the sign. So if they're positive, they become negative. If they're negative, they become positive. All of them happen to originally be positive, so they're all going to change their sign. So that's a -4, -8, -6, -2. So to give our final answer, we just need to plot these ordered pairs. So we've got -4, 1, 2, 3, 4, -1, that's L prime. M is at -8, -5, 1, 2, 3, 4, 5. N is at -6, -7, N prime, and P is at -2, -3. So this should be the final answer once we've done all that we are supposed to do. So you can draw it out by hand, never wrong, or you can look at some of the tricks that we've done. So number 12 is the only other one for you to try on your own, and watch out because this is not an axis. You do need to draw the line and flip it. So recapping the ones to try on your own from this lesson, you need to try numbers 3, 4, 5, 6, 8, and 12. 3, 4, 5, 6, 8, and 12.